So explained variation. So this is our last topic in this particular section. So as stated before, there is some variability in the dependent variable values. So our dependent variable is y. It's also called the response variable. And in this case, that was calories for us as we were looking at the beer example. So some of the variation in calories is due to alcohol content, and some is due to other factors, such as other ingredients in the beer. So how much of the variation in calories, so we're looking at the variation in y, is due to or can be explained by the alcohol content, which for us is our random variable x. So you can have two beers at the same alcohol content, but beer 1 could have higher calories because of the other ingredients. So some variability is explained by the model, and some variability is not. So now this coefficient of determination gives us the proportion of the variation in y that is explained by the model with x as its predictor variable. So if we write that definition in here, so this coefficient of determination measures the proportion of the variation in y that is explained by the linear model with x as its predictor variable. Now the coefficient of determination is the value next to r squared on your linear regression t-test output screen. It's also in the output box in StatCrunch, and it really is just the value of r that's squared. And this proportion is often changed to a percentage when its value is interpreted. So in example 10.2.3, we're asked to find the coefficient of determination for the beer data in example 10.2.1. So now if we go back to that data back in 10.2.1, so let's see here. Go back to that output screen. Okay, so r squared here, if we round that off to 3 decimal places, is about 0.834. So r squared here is about 0.834. And so now if we interpret that in the context of the data, that tells us that about 83.4% of the variation in number of calories is explained by the linear relationship with alcohol content as its predictor variable. So it doesn't do 100% of the explaining. Okay, so if we take 100% minus 83.4%, we get 16.6%. So the other 16.6% of the variation in calories is due to other factors. Okay, so at the end of the day, when we have these linear models and we've got one variable that's helping us predict another one, it's interesting to know what percentage of the variation in the outputs can be explained by the thing that we're trying to use as the explanatory variable. Okay, so an explanatory variable, a good one, should do a lot of explaining, and so r squared should be close to 100%. Okay, so now that you have a correlation coefficient for the sample data, how can you tell if it's significant or not to determine if this linear relationship exists for the population of objects? So keep in mind, in the study, we only had 9 beers. Okay, there's a lot of beers out there. Okay, so 9 seems like a pretty small number of beers. So how can we generalize this out to the population of objects? So this will be answered in the next section.